Hiya folks, so this is question 3. So they ask us for the volume of the cuboid. So volume of the cuboid is just length times width times height. So the problem here obviously is that you don't know what the length, width and height are. The length is obviously y, the width is x and the height is z. So you're going to have to do each of them, but we need to work out what x, y and z are, and they've told us what the areas are. So the area, if you take the front of it there, the area of that is just the length times the width. So it's the x times z. So x times z has to be equal to 2 root 2. We also know that the area of the big part on the side, the right hand side there, so the 8 root 6, that has to be what z times y is, or yz. So yz is equal to 8 root 6, and the top part then, that's x, and then that is y, so we know that x, y is equal to 4 root 3. So we have to use this information to figure out what x, y and z are. So if you just look back at the first equation, x has to be equal to 2 root 2 over z. So we're just going to start subbing things in and we'll see what happens. So if I use that then and put it into the third one, so we can put 2 root 2 over z times y is equal to 4 root 3. And then I've got two equations then with just z and y, don't I? So this and this. Let's use the middle one here. Let's get what y is, and then we'll have things with just z. So y then has to be equal to 8 root 6 over z. So I'm going to sub that in into the third one then. So 2 root 2 over z times by 8 root 6 over z has to be equal to 4 root 3. So I've got an equation then with just z's in it, but it looks a bit complicated. So if I multiply the 2 on top, you can do it on the calculator. 2 root 2 times 8 root 6, I'm getting 32 root 3. Over z squared is equal to 4 root 3. If you multiply both sides by z squared, you get z squared 4 root 3 equals 32 root 3, and then if I bring across the 4 root 3, so I get 32 root 3 over 4 root 3 has to be equal to z squared. So then we're going to divide those two, and I'm just getting 8 then. So 8 is equal to z squared, and then if you do the square root of 8, that has to be what z is. So z is square root of 8. Now I can break that down a little bit. I can call it, you could just stick it into the calculator, root 8, and it'll kind of break it down for you a little bit. So that's 4 times 2, so that's just going to be 2 root 2. So 2 root 2 is z. So I know that 2 root 2 is z. So let's just use that then. Let's go back up and put it into one of the other ones then. Yeah, so I'm going to put it into this one here. So x is 2 root 2 over z. So x is 2 root 2 over z. So if x is 2 root 2 over z, but z is 2 root 2, well then x is 2 root 2 over 2 root 2. So x has to just be 1. So x is 1. So that's simple. That makes it a little bit simpler for us. And then let's put it into this one then. So y is equal to 8 root 6 over z. And then let's put in what z is again. So z is 2 root 2. And then you can just divide those easily. So 8 divided by 2 is 4, and root 6 divided by root 2 is root 3. So y has to be equal to 4 root 3. So that worked out nicely in the end. So the part where we had to find out where we found out z was a bit complicated, but the x and the y were easy enough to find. If you look back at the question, it asked us to find the volume of the cuboid, so we need to do the length times the width times the height. So that's just going to be x times y times z, and we know what all of them are now. So volume then is just x, y, z. Basically, you're just multiplying them all by each other. So you do 2 root 2 times by 1 times by 4 root 3. So each just what x, y, and z are. So we're going to get 8 root 6. That doesn't break down any further then, I think. So that's just going to be our answer. So 8 root 6. Yeah, it's in centimeters squared as well, so you can just put in centimeters squared for your units. No, sorry, cubed, sorry, centimeter cubed. The areas are in centimeters squared, so volume's always centimeter cubed. So that's our answer. So there's nothing too difficult in that part, but it's just got a little bit complicated there where we're finding out z, but there might be an easier way to do it as well. If you sub in one of the others instead of z, or if you try to work out x or y first, you might do it a little bit easier. But it's just subbing in anyway. Right, part B then. So we're given this just a quadratic, and we just need to factorize it first of all anyway. For the first part, so 3x squared plus 8x minus 35, and it's when f of x is equal to 0. Now there's a few different ways of factorizing a quadratic like this when you've got a number in front of the x squared. This is the way I do it usually. So we're trying to find factors for minus 35 anyway. So you could have 1 times 35, the obvious one anyway is 5 times 7 for 35. I don't think there's really any other factors. 2, 3, 4, they don't divide in. So that's it. It has to be one of those two. And then you're putting them in then, so it's not, so whatever you put down here must be multiplied by 3 first, because the arrow goes that way. In order for when they're added together. So I'm going to try 5 and 7 because I think that's what it'll be. So if I had 5 there and 7 there, 3 times 7 is 21, and then maybe take 5 is 16, so that doesn't get us what we want. So it's probably the other way around. So 5 there, 7 there. So 3 times 5 is 15, and then if you take 7 away from that, then that's 8, isn't it? So that's what we want. So we just need to figure out the signs. They must multiply to give a negative. Okay, the negative here. Therefore, one of them has to be negative. Because it's a positive here, then the bigger one is going to end up being positive. So that has to be a plus 5, and this is going to be minus 7. So just double check then. 3 times 5 is 15. Take away 7 is 8, positive 8, so that's what we want. Then when you're putting them into the brackets, that's going to be one bracket there. You read them across then when you're putting them into the brackets, and that's going to be the other bracket. So 3x minus 7 and x plus 5. Those are the brackets equals 0. So either 3x minus 7 equals 0 or x plus 5 equals 0. The x plus 5 one's easy enough. X equals minus 5. The other one you have to do 2 steps, so 3x is equal to positive 7 because you move across to minus 7, and then x is equal to 7 over 2. So x is 7 over 2 or x is minus 5. So those are our two answers. Actually, I've made a mistake there, haven't I? That should be over 3. Because you're bringing across the 3, sorry. So 7 over 3. So 7 over 3 and minus 5, they're your solutions. Right, so for the last part anyway, we actually have a lot of the work done already. What you should be able to see, and it even tells you here hence or otherwise as well. So this here is actually the same as what the quadratic that you solved in the first part. So if you were to rearrange around that there, 3 to the power of m plus 1, so if you just put everything on the, 2m plus 1, if you put everything on the left hand side, then bring over that minus 8, 3 to the power of m, so it'll be plus 8, 3 to the power of m, and then bring over the 35 and it'll become minus 35 is equal to 0. So that looks exactly the same as this up here, what we solved before. It's just that instead of m, or a 3 to the power of m, 2m, or 3 to the power of m, we have x up in the upper one. So remember that there in the first thing, that's the same thing as 3 times 3 to the power of 2m plus 8 to the power of, 8 times 3 to the power of m minus 35 equals 0. And that's the same thing as 3 and 3 to the power of m to the power of 2 plus 8 times 3 to the power of m minus 35 equals 0. Now you don't really need to show this bit what I've just written there in the exam. I'm just writing this out just to show you that it's that there is the same thing as that up there. It's just that instead of an x, there's a 3 to the power of m. So we've actually solved for 3 to the power of m in the last bit. So our answers were here, and that's why it says hence or otherwise. So I can let 3 to the power of m be equal to 7 over 3, or 3 to the power of m is equal to minus 5. So I can use those two solutions already, just because I've already worked out what that quadratic would be. So we've got two possible solutions then. Now this one here actually, we can rule that one out. The reason is because of the minus. Okay, so 3 raised to some power equals a minus, so that can't have a solution, because you can't do 3 to the power of anything and get a minus 5. So you can rule that one out. If you tried to go off and use logs to solve it there, you probably wouldn't lose that many marks, but you won't obviously get a solution. This one we can solve that. So there's a clue up there. It says to give you the answer in the form log 3p. So it even tells you what kind of base there you should have. So log 3p minus q. So obviously we have to use logs then. So we're just going to do log 3 on both sides. So I'm going to do log to base 3, 3 to the m is equal to log base 3 7 over log base 3 to the power of 3, or to 3. So one of the rules of logs is you can bring this down and put it in front of the log, so we get m log 3 is equal to, and then I can use the division rule of logs, so I can write this out as log 7 minus log base 3. Now if you're thinking about what this is, log 3 to base 3, that's just, so 3 to the power of something equals 3, well it has to be 1. So that thing there is just 1, and you could put log 3 to base 3 in your calculator and it'll just give you 1 as well. So that's going to be m to the power of, m times 1 is equal to log, we'll just leave that one as it is, because that one, if you put that in your calculator you just get a decimal anyway, and then this here is exactly the same as the thing on the left hand side, so that's 1 as well, so minus 1, and we're actually done then, I think. So m is equal to log and minus 1. So that's the form they wanted us to give the answer in, log to base 3 p minus q. So p in this case then would be 7 and q is 1. So that's all then for this question.